All right, guys, so the formula we're using today, and you guys have seen it before, it is the formula we use for exponential growth and decay. All right, y equals ab to the x. And when we were graphing, guys, remember that a was our y-intercept. Okay? In word problems, our y-intercept is actually our initial amount. Okay, so when we're talking graphically, a is our y-intercept. Okay? It is where it starts on the y-axis. In word problems, our y-intercept turns into our initial amount, okay? Because when we're talking about word problems, and we're talking about time, and stuff like that in years, remember that we can't have negative time. And so our y-intercept corresponds to our initial amount because that's time of 0, okay? Our b is our base, okay? Or our multiplier. When we're in word problems, that's going to, our multiplier is going to be having to do with our rate. However, guys, because we use the same formula for growth and decay problems, we have to make sure that we indicate in our formula whether this is a growth or a decay problem. If it's a growth, we're going to do 1 plus our rate. If it's a decay, it's 1 minus our rate. Okay. Remember, the rate that they give you is going to be a percent, and you have to turn it back into a decimal. And so an easy way of doing that in your calculator is to divide your percentage by 100, and it'll move the decimal place for you. All right. Or you can know how to move it. It's just 2 places to the left. That's where you're going to move your decimal. Okay. And then x, guys, is going to be our time frame. All right. All right, so let's see how we do with these. So in number 1, it says Tammy deposited $400. And again, like if you guys watch my warm-up, I always like to highlight the numbers in the problem. Okay, so that I can go back up real easily and say, okay, well, what variable does this number represent? Okay, so Tammy deposited $400 money into a savings account that receives 5% interest per year. Okay. How much will she have in her account in 5 years? So if she doesn't deposit or withdraw any money, so that just tells you that you don't have to worry about, what she takes out or what she puts in. Okay. And so here we go. So we're going to start off with y equals, oops, I don't want to be a highlighter. I want to go back to my pen. So I want to have y equals ab to the x. And I know that this is exponential because anytime they give you a percentage, when you are multiplying by a percentage, okay, it becomes exponential because a percentage on one amount will increase it or decrease it depending if you're growth or decay. And then the percentage on that amount will go up even more or down even more, okay? And so it's exponential anytime they're using a percentage, okay? So now that I know what formula I'm using and why I'm using it, in that formula, we have 4 variables, basically. We have y, we have a, we have b, and we have x, okay? Y is what she's going to get out. That's always going to be our final amount or our output. Okay, we don't know what she's going to get out after putting this money in. Sorry. All right, so our A value we said is the initial amount, which is what she's putting in, which is $400. That's where she's starting off at. Okay. Our B value, when you put money into a savings account, remember that that's always going to be growth. And so our B value will not just be our rate, it'll be 1 plus our rate in order for it to grow. 5% is going to change to 0.05 as a decimal, okay? So it'll be 1 plus 0.05. Our X value is going to be our time frame, which is going to be years, and it's going to be 5, okay? Notice that your rate is per year and that our time frame is also in years, and so we don't have to do any converting or anything like that, which is good. All right, so we're ready to take our information and we're ready to go ahead and plug it in. All right, so remember that our formula is y equals ab to the x. That's for exponential growth or decay. We don't know our y value or our output, but we know that we are starting with $400. We know that our b value is 1 plus 0.05, which is 1.05. Notice it's over 1, which is going to make it grow. And then we're going to be doing this for 5 years. All right. So all we have to do now is grab our calculator, okay, type it in just exactly how we wrote it. And when we're done, we're going to end up with $510. And always copy down your decimals. So 512.625. And that should be a good amount of decimals to copy down. It does keep going. Okay. And she wants to know how much she's going to have. So because there are no rounding directions like nearest dollar, nearest penny, nearest 10 cents, or anything like that, with money, we're always going to go ahead and round when there's no rounding directions to the nearest cent. And hopefully you guys know that that's the second decimal place, but you still have to look next door. Okay. And so when we round this, this is going to be $510.51. Okay. And that's how much money she's going to have after 5 years. Notice she started with $400. It grew to $510.51. And this question's done. All right. So we're going to go ahead and look at the next problem. And it says that Ryan bought a new computer for, and again, guys, I always like to highlight 2,000. Oops, that's not my highlighter. Okay. $2,100. The value of the computer decreases. So this is a decay question by 43% each year to the nearest dollar. There's our rounding directions. Okay. Will the computer be worth in 3 years? All right, so because it's a percentage, we know that this is going to be exponential decay. And no matter if it's decay or growth, we use the same formula. And we have the same exact variables in it. Except because this one is growth, our b value will be 1 minus our rate. And 43%, move the decimal place over 2 places to the left or divide it by 100 is 0.43. Okay. Our a value, which is our initial amount, is 2,100. That's what the computer's starting off at. And we want to know how much it's going to be worth after 3 years. And again, notice that our percentage is per year and our time is in years. So we have to do no converting. Okay. All right, guys, all we're going to go ahead and do is plug it into y equals ab to the x. Again, we don't know y, so it can stay y. Our a value or our initial amount is 2,100. Our b value is 1 minus 0.43, which if you do in your calculator is 0.57. Okay, and so what that means is that that's how much it's growing. And because it's less than 1, it's actually decreasing. Okay, and then our time frame, which is our x, is 3. And all we're going to do is type that right into our calculator, exactly how you wrote it. And when you hit enter, you should end up with 388.9053. Okay. And if you remember that we did have rounding directions to the nearest dollar, that would be this spot, but we have to look next door. And because that's 5 or higher, because it's a 9, that means it's going to move that underlying number of 8 up. All right, and so we're going to say that this is now going to cost us $389. So that's the value of the computer after 3 years because it decreases by so much because technology keeps coming out, and so they make the older stuff cheaper. All right, and so this one's finished. All right, so number 3. Which of the following gives the savings S in an account of $250? Was invested at an interest rate of 3% per year. So we don't have to go ahead and type it into our calculator. They're just asking us how we would set it up. But because they are talking about a percentage, we know that this is exponential, and so we use y equals ab to the x. We don't know how much the savings will be, except they're using s instead of y. Our value in our account is $250. That's our initial amount. And because it's a savings account, it's going to grow, so 1 plus. Our rate of 3% is going to be 0.03. And we don't know how much time, but if you look at all your choices, they're using a t instead of an x to represent our time frame. And so all we have to do is look for this choice. However, in our parentheses here, they're going to go ahead and do the math there. 1 plus 0.03 is just 1.03. Notice that it's over 1, which is why it's growing. Okay? And hopefully you guys can match that to choice number 2. All right, let's take a look at the last one on the page, number 4. It says if the population of a town is decreasing. So we know that this is decay. So we'll have to make sure we do that in our formula. 4% per year, and started with 12,500 residents. Started with, okay, which of the following is a projected population in 10 years? All right, so because they're using a percentage, we know that, we know that this is y equals ab to the x. We don't know what the final amount is going to be, so we can keep that as y. We know that the initial amount is 12,500. We know that it's a decreasing, which is 1 minus, and 4% will be 0.04. You can either divide 4 by 100 and it'll move the decimal place for you, or you can move it 2 places to the left. Okay? And our years, notice that the percentage was per year, and our time frame is also in years. And so we can go ahead and assume that we don't have to do any converting. Okay. 1 minus 0.04 is 0.96. You'll notice, guys, that number's under 1. And so when we use a multiplier that's under 1, we're going to be decreasing or decaying. Okay. All we have to do, guys, is type that right into our calculator, exactly how it looks, and we're going to end up with 8,310.40795. And because this is multiple choice, we'll just make sure that we pick the right number, and there's not anything even close to wonder if we have to round or anything like that, and so it's choice 4. All right, notice that your population decreased, right? You started with way more people or residents than you do have now. All right, guys, I'll see you guys on the backside for a couple more examples.